Hello, we're going to go through tutorial number 4, which is setting up JULES to do a gridded run and look at some of the output. This is using a tutorial setup that Toby Mark uses set up. You can go to his website and look at other tutorials. There'll be hyperlinks on this page by the time I finish this video and published it all. The first thing we need to do is get hold of the data that goes with this tutorial. So we're just going to take this website here. We have all the data there. And we're going to download all this data. I'll pause the video whilst I do all this because this is boring. Okay, so they're all downloaded. We'll unzip everything using this little for loop here. Hope you can see that. Okay, all data downloaded. So we're now going to open up our Rosy Go and copy and check out the suite UAM539. So cache our password. Search for UAM539 in the search bar. We will copy the suite. Okay, so that's the name of my suite there. It's UBE742. That'll be a useful number to remember later. But we'll just open this up with the rows edit by double clicking. Like the previous examples, this is already pointing to a metadata that is visible on my file system. You may have to change these FCM make and JULES metadata directories so that your metadata is findable. Something I forgot to state at the start of the video, I'll do some editing to make this appear at the right time later, but you should have updated your FCM make configuration to match your machine you're working on. So follow the steps that were outlined in tutorials 1, 2 and 3, etc. Or if you know what you're doing, just go to the FCM make build configuration and fill in this page so that it matches your machine settings. And we should be pointing to the JULES version 5.2 release with this experiment. So following Toby's instructions, we've checked out the suite. We need to update the paths of the ancillary files and the driving data. So ancillary data, there are various files here. We could go through all these, updating the file names. What I'm going to do, another one there, to show you how to do this by editing the text files, which is a lot quicker when you become a bit more of an advanced user of rows and JULES. So we'll close this GUI for now. We'll open up another terminal, and I'm going to navigate to my roses directory. We want to plug in this row suite here, so it can be there. You can see there's two directories there, one called app, one called meta. I'm going to go into app because basically JULES is an application within this suite. You can see you've got the FCM make and you've got the JULES part, so FCM make builds your model and JULES is where the model runs with all its settings. And there are various things in there. What's important is this rows app configuration file. So we'll vim rows app configuration, and we want to replace all those file names. So one of them was the JULES frac, so this is the file we need to replace with this file we just downloaded. And they've actually all got the same file name, they're just in a different folder. So what I can do is use Vim's fancy search and replace methods. We'll take this directory and we'll replace it with and that should actually do it on my driving data as well. Oh no, I need to change the directory there as well. And something else that we need to do, which isn't in Toby's tutorial, I just found it whilst running this myself, is we need to change the start of this driving data, because when JULES initializes, it opens up the first driving files, which won't be there because you've only downloaded the June data for 2003. So we're going to change the data start to correspond with that. So 2003 06 01. We now want to update our output directories. I actually did this once already. I'm cheating, I'm going back in time. You can see here this output directory is pointing to my JULES tutorial directory that I've created in my home space. And then the rows task name, you can change this if you want. This is just a default rows environmental variable, which takes the name of the task. And in this case that's JULES. Okay, so we should be good to go. So you can, everything is saved, and I can hit the play button, and hopefully that will all go. I'll come back once the rows, once the suite has run and completed. Okay, so that run has completed successfully. You can tell because there's nothing left in this silk GUI. I'll close that up. And now we're going to plot the data using a little plotting script that I created. So we're on step 7. So we'll navigate to the output directory, which is here. You can see it's created all these files. If we go in nc.-h, we can have a look at what's in this output file. See there's loads of variable. JULES gives you all the metadata. It's not quite CF compliant, but it nearly is. Okay, so and now we want to plot the data using my script. We can export this plotting script from the repository using this command I've included here. And we can execute it using, I'll update this later. You have to include the Python bit at the start. So what we're doing here, we're using Comyn-Platt 2.7. We're calling this routine I've created, and then this routine requires 3 input arguments. So the first one is the file name that we want to plot, so that's jules.base.nc. The next one is a variable we want to plot, which in this case is the T-star grid box. That's the skin temperature. It's a grid box mean. Oh, that's the, not the grid box mean, that's just the T-star. There we go. And the next variable is how to treat the time dimension. So we just want to take the mean. And then the last one, which is set to none, is how we treat the Z dimension. It's set to none because we're using the grid box mean, so there is no Z dimension. If you want to use this for the script for other purposes, take a look at the code, and it's fairly self-explanatory. So there we go, that's the grid box mean temperature. Feel free to use that script to have a look at a few more variables, and maybe set up the run with a couple of parameters changed and have a look at the differences between 2 runs. You've got all the tools there to have a bit of a play around.